when we did this before, this distance here is going to be v times t, and so this is 1/2 vt, this is h, and this is the square root of h squared plus 1/4 v squared t squared. And so the speed of the light in this case was 2 times the square root of h squared plus 1/4 v squared t squared over that's distance over time. And that is equal to the speed of light down here is just 2h over the proper time. If we solve for h in each, actually, I just need one of them. We'll take that one. I'm going to solve for h, so I get ct is equal to 2 times the square root of h squared plus 1/4 v squared t squared. Square both sides, divide by 2, or 4 if I square first. 1/4 c squared t squared is equal to h squared plus 1/4 v squared t squared. I'm going to bring that over to the other side. And the reason I'm doing that is that in this example, h is the same for regardless of how fast the box is moving. So h is a constant here. Don't want to use that. And so if I multiply by 4, I get 4h squared, which is just some constant. It's going to be c squared t squared minus v squared t squared. This relationship here is constant for everybody. So no matter which point of view we are taking, that's going to be the same. So those are the two things that are the same for everybody. All right, we still got a problem that we need to resolve here. Questions up to here? I'm in a car. In the back of a car, and I throw the baseball forwards. I know that the velocity of the ball with respect to the ground is going to be the velocity of the ball with respect to the car plus the velocity of the car with respect to the ground. This is just vector addition. This is as long as those letters there are this referring to the same thing, it's completely legitimate regardless of whether it's 1 dimension, 2 dimensions, 10 dimensions, whatever. So if I throw the ball, so from the car's point of view, if I throw the ball at 50 miles per hour, and the car going relative to the ground, in other words, what we generally consider the speed of the car, so if that is VBC, we'll just take to the right as positive. VCG is, let's go in 60 miles per hour relative to the ground. What is the velocity of the ball with respect to the ground? It's like I'm not the only one who had a lack of sleep.
to 110
Yeah.
miles per hour.
Just add them up. So if I had a radar gun and I was able to hone in on the baseball itself, if I'm on the ground, I would see the cars going, if I'm aiming at the car, it's going 60 miles per hour. I aim it at the baseball, it's going 110. So I can conclude that the ball is being thrown at 50 miles per hour. Just add it up. This is known as Galilean relativity. Now let's take a look at special relativity. I'm in a rocket. And according to me, I am throwing a baseball here. So the velocity of the ball with respect to the rocket is 0.6 times the speed of light. The rocket, the velocity of the rocket with respect to, let's just say, Earth, is 0.9 times the speed of light. So, if Galilean relativity is true, then the velocity of the ball with respect to Earth would be the velocity of the ball with respect to the rocket, plus the velocity of the rocket with respect to the Earth, which would be 0.6 c plus 0.9 c, or 1.5 times the speed of light. Which is an issue. Because how do you get something above the speed of light? And we look at our time dilation formula. If I start out slower than the speed of light and I get past the speed of light, I have to be at the speed of light at some point, without the rip in the space-time continuum. I know that t is equal to Tp over the square root of 1 minus v squared over c squared. So if the speed of the object is the speed of light, what's going on in the, if v equals c, what's the relationship between, what does t equal? Pardon?
T1 equal TP.
Nope.
U equals 0.
Nope. If v is 0, then t is equal to tp. However, and if v equals c, we don't get, the whole thing's not equal to 0. Despite what my son's second grade math teacher said. All right, so what happens, if v is equal to c, what do we get in the denominator?
0.
So as v approaches c, what happens to the fraction? You sort of see it somewhat here. As beta gets closer and closer to 1, gamma gets bigger. What happens when we get really, really close to, when v is really, really close to c? This is a math question, not a physics question. What happens when you divide by a smaller and smaller number?
You get a larger number.
Yes? If v equals c, we end up with Tp over 0, which mathematicians say can't be done, which physicists say it's equal to infinity. The mathematicians are technically right. The physicists are talking about limits. But this is the reason why, if something were traveling slower than the speed of light and suddenly got to the speed of light, one, it would require an infinite amount of energy to do that. But also, time would no longer have any meaning for that object. The entire universe would live out its life in the moment that that object hit that speed. Photons experience no time. From their point of view, the universe came and went like that. So the problem here is that if I start out slower than the speed of light, I can't get above the speed of light. So this is a problem. And then some physicists at some point said, well, if it starts out faster than the speed of light, it will never go slower than the speed of light. And so the theorists came up with these mythical particles called tachyons, which no one has ever seen. The trouble is, if we're traveling faster than the speed of light, time gets a little funky there, and we have to redefine what time is. But if I shot you with a tachyon gun, you would get hit by the tachyon bullet before I pulled the trigger. So there's some funky stuff that happens if we suddenly start allowing for that. But some say that it might exist. It's one of those theoretical things that you throw against the wall, and if it sticks, you're heralded as a genius, and if it doesn't stick, it falls into the dustbin of history, like most of the theories. However, this last resolution is dealing with how do we actually add velocities so that that doesn't happen. And that will have to wait until another day. Have a wonderful weekend.